Okay, here's the fun second half of these rational equation solving deals. On the second part of it here, we have some messier denominators, it looks like. So that ought to be fun. So we're going to do 21 through 29, and I'll explain them as we go. So number 21, this one, nice and easy. 3 over x is equal to 5. My only denominator is an x, so I'm just going to multiply each term by an x. And when I do that, I get 3 is equal to 5x. And so then I divide by 5, and I get that x is 3/5. If only they were all that straightforward. Let's do 22. 1 over 3x is equal to -2. My only denominator is a 3x, so I'm going to multiply everything by a 3x. The 3x and the 3x will cancel, leaving a 1 equals -2 times 3x is -6x. So then I'm going to divide by the -6, divide by -6, and I get that x is -1/6. And there we go. At this rate, this will be a short video. But then we get to some that are a little more unpleasant. 27 will be kind of a breather though. 23, so I'll clear this out. 23, we have 2 over an x minus 1 is equal to a 4. So my only denominator is x minus 1, so I'm going to multiply by an x minus 1. And I'm putting it in parentheses because if you have something that needs to be multiplied, it's going to have to be distributed to both those pieces there. I'm not going to have to distribute on this one because this x minus 1 and that x minus 1 are going to cancel out. So this is going to be 2 is equal, and then I'll have to distribute. So I'm going to get 4x minus 4. And then I have a pretty straightforward equation to solve. I'm going to add 4, and I get 6 is equal to 4x. When I divide by 4, I get x is equal to, let's see, 3 over 2, if you'd prefer 1.5, or as a decimal, 1.5, whichever format you'd like that in is fine. So that wasn't so terrible. So let's do 24. 24, we have 4 over x plus 3 is equal to 5. Again, my only denominator is x plus 3, so I'm going to multiply both sides by an x plus 3. And I'm putting it in parentheses to remind myself to distribute here. It's going to cancel out the x plus 3 there. That's actually why that step is what we're doing. 4 is equal to 5x plus 15, because we have to distribute the 5. So then I'll take away the 15, take away the 15, and I get -11 is equal to 5x. And when I divide by 5, I get x equals -11/5, or -2 1/5, or -2.2 if you'd prefer a decimal. So there was 24. Oh, it wasn't too bad. 25. Let's go 25. 25, we have a 5x minus 2 over an x minus 4, and this equals -3. Now, something I didn't mention on those other ones, I didn't even check, but it's okay because it didn't work out. But each time you get one, you need to make sure that your answer that you get does not make a denominator 0. So like if we got x equals 1 on number 23, we didn't. But if we did, x equals 1 can't be right because 1 minus 1 will give you a 0 in the denominator. So if we had gotten -3 on number 24, that would not have been a correct solution, because -3 plus 3 would give you a 0 in a denominator. So here, if I solve this and get 4, that's not an answer because 4 minus 4 would give me a 0 here. So let's see what happens. My denominator is x minus 4, so I'm going to multiply by x minus 4 on everything. So when I do that, this x minus 4 and that x minus 4 cancels, which is kind of nice. So I get 5x minus 2. On this side, I have to distribute. I have to be careful, a negative, and then that's a minus. That's going to end up being plus 12. We're going to get negative 3x plus 12. And so I want x's on one side, constants on the other. So I'm going to add 3 x's. And I get 8x minus 2 is equal to 12. And when I add 2 and add 2, I get 8x is 14. So when I divide by 8, it doesn't divide evenly. It does reduce, I guess. What is that? 7 over 4, which would be 1 3/4 or 1.75, whichever you prefer. That is not going to make a denominator 0, so that's just fine. So let's move on to 26. Number 26. We have 3x minus 1 over x plus 2, and that's equal to 7. My only denominator is x plus 2, so I'm going to multiply every piece by an x plus 2. The goal being to get rid of the denominator every time. That's my first step. Get rid of my denominator. So the x plus 2's are going to cancel. We get 3x minus 1. Here the 7 must be distributed, so we get 7x plus 14. I want x's on one side. I like positive coefficients, so I'm going to take away 3 x's from each side. And that'll get my x's only on the right side. So I'm going to get negative 1, because this taking away 3x does not get rid of that. So then I get 4x plus 14. And then I'll take away the 14, because I want only x terms on this side. So we're going to get negative 15 is equal to 4x. And when I divide by 4, that's a little unpleasant. What is that? Negative 3 3/4. It'll be negative 15 over 4. Goes in there, yep. Negative 3 3/4 or negative 3.75. Or maybe negative 15/4 if you prefer that one. 27. Number 27. We have 2 over x is equal to x over 2. So my common denominator is going to be an x, and a 2 is going to be a 2x. So I'm going to multiply this by 2x and this by 2x. So here the x's are going to cancel, and 2 times 2 is 4. Here the 2's are going to cancel, and x times x is x squared. So I have that x squared has to equal 4. And so I don't know how you ever taught, so I would solve it by doing the square root. But anytime you do square root, you have a positive 1 and a negative 1. So the square root of an x to the second is just going to be an x. But here it's either going to be a positive or a negative 2. So I have two answers. X could be 2 or x could be negative 2. So those are my two possible answers. Neither one of those will make me have a denominator of 0, so both of them are good. And if you think about it, 2 divided by 2 and 2 divided by 2, both sides equal 1. And then if you make x negative 2, it's going to both sides be negative 1. So it does work out. 28. Whoa, 28. I'm going to figure out my little buttons on my pen here. We have 2 over an x plus 3 is equal to an x minus 3 over a 2. So I put parentheses around that because I know I'm going to be multiplying, and I have to be careful of that. But my common denominator is going to be a 2 and an x plus 3. So a 2 and an x plus 3. Oop, 3. And then 2 and an x plus 3. And here the x plus 3's are going to cancel, leaving the 2 times 2, which is 4. Here the 2's are going to cancel, and I have x minus 3 and x plus 3. And so I have to multiply those. I don't know if you all have been taught enough, but those are they're conjugates of one another. So since one's a plus and one's a minus, When I multiply them, all I'm really going to get is x times x, which will be x squared, and 3 times 3 is 9. I'm going to get x squared minus 9 because the outside and the inside parts will cancel out if they are conjugates. So then we end up with a horrible answer here. Get x squared is equal to 13. So when we do that little square root business, we get that x is either the positive or negative square root of 13, and that is horrible. So I guess that's a little unpleasant. However, at least maybe that explains number 15 not working out. The square root of 13. So positive, what is square root of 13? It's going to be 3 point something, because 4 would be 16. So yeah, it's plus or minus square root of 13. Guess I could check to see if that's right. I'll type this in real quick here. 2 divided by the square root of 13 plus 3. And then we have the square root of 13 minus 3 divided by 2. Hey, it works. So those two horrible answers there are correct. So one more to do, number 29. Number 29, we have 2 over x minus 1 plus 3 over x plus 1 equals, and you told me this was 4. So my common denominator has to have an x minus 1 and an x plus 1. So I'm going to multiply each of these three pieces by both of these things. So I'm going to write kind of small here so I can squeeze it in. I'm going to get an x minus 1 and an x plus 1. And x minus 1 and an x plus 1. And then an x minus 1 and an x plus 1. And on the first one, the x minus 1s are going to cancel. So this 2 gets multiplied by an x and a 1. So it's going to be a 2x plus 2. On this second piece, the x plus 1s are going to cancel. So this 3 gets multiplied by the x and the negative 1. And we get plus 3x minus 3. Over on the right side, these two are conjugates. So this part's going to be x squared minus 1. X times x, 1 times 1 with a minus sign. The outside and inside will cancel. But then this 4 gets multiplied by both these. So this is going to be 4x squared minus 4. And we have lovely quadratic situation here. So I'm going to simplify things and then get it equal to 0. So I'm going to put the x terms and the constants together here. So this is going to be 5x minus 1 is equal to 4x squared minus 4. And I want everything on one side, so I have a 0. So I'm going to take away that 5x and add a 1. Take away a 5x and add a 1. So those will cancel, those will cancel. So I'll get 0. I have a 4x squared minus 5x. And then minus 4 plus 1 is going to be minus 3. And this may or may not factor. It could be horrible. Let's see. B squared minus 4ac. So what is that? 25 minus 4 times negative 3. Hey, that's horrible. So x is going to be negative b, which would be 5, plus or minus the square root of a negative 5 squared minus 4 times a 4 times a negative 3. That's b squared minus 4 times a times c. And then it's all over 2 times a, which is 2 times 4. The inside of that, I just typed it in. If you take 25, which is the negative 5 being squared, minus 4 times the negative 3, I get 73. So I get 5 plus or minus the square root of 73 over 8. And that is horrible, but I'm going to go with it. So that's 21 through 29. Hope this helps you out.